Good evening, everyone. Welcome to the last session for today. Uh, Today, in the last session, we have Mr. Saro. He's the founder and director at H2 Energy SRL. For the first presentation, he'll be talking about hydrogen and its relevance for the power sector. Mr. Saro, please go ahead, sir. We can have your presentation now. Thank you. You
Hello?
are on mute. Mr. Saro, you can go ahead with the presentation.
Okay. Sorry, I had the problem with my connection. First of all,
we are live, sir. Please go ahead.
Yes, I'm here. Okay, thank you for this invitation. And since the delay, I will go straight away in the presentation. And myself, I'm the CEO of the H2 Energy, is a company that is producing electrolysis systems for industrial use. We are okay. There is a bad connection. Okay, and we are Italian entity. We work we mainly in Europe in this moment, and we have more than 20 years experience. 20 years experience in the construction and commercialization of electrolysis system. We have actually in our portfolio almost all the technology available, starting from the alkaline system, from the PEM system, the protonic exchange membrane, and also the innovative anionic exchange membrane. I will go in detail later about this technology, and then a link with the thematic of this conference. We are also developing the high temperature, high pressure systems, working at 500 degrees and high pressure, although with the ceramic protonic stack. We have to see the in this we can say technology in this industry. Sorry. In this technology, in this we can say field, Europe has a limited capacity in this moment of production of this kind of equipment. We are speaking about a capacity last year of 70 megawatt, but with a request in the market of more than 40 gigawatt. So there is too much to do, a lot to do, and we are ready to answer to the request of the market. The technology available are in this moment, as I told you before, Alkaline, where this is the oldest technology, where we work with 30% solution of alkaline medium, and this is we can say a technology that in this moment is going to be abandoned in the next future. The actual technology that is more popular is the protonic exchange membrane that has the use of catalyst of high expensive and not so easy to find catalyst like a platinum, iridium, ruthenium. But this is, we can say, the state-of-art and most flexible plant. Our company in this moment is developing the technology of anionic exchange membrane that is normally it is produced as a small capacity, but we are able to produce even a single stack 1 megawatt, and we are now entering in this megawatt scale next year. This will change, will be a game changer, will be in the industry. In fact, we have simplified the technology. The layout of the plant, the balance of plant is more, we can say, simple. In fact, we optimize the system and we are in the position to produce this kind of systems at even a large scale. This starting from next year. This is something that is new in the market at a large scale. Actually, the difference are mainly in the membrane and in the working conditions. It is sure that since our simplification of the system, as you can see, this is the two systems compare the PEM and the ion exchange membrane. We are in the position to offer plant that can cost even up to 50% cheaper than the PEM system of alkaline system. In this moment, we can say that the technology are mature. We can say about the PEM system, and it is possible to enter in this market if it's possible to get more use of these products more widely. Will be easy also to increase the capability, also optimize the cost. Coming back to our topic, we see a big developing in the future also for the production of high temperature systems working using the we can say off gas of a factory like steel factory, cogeneration plants, thanks to the use of ceramic plants, ceramic stack. This will be, we can say, will allow a saving of energy, since the part of the energy to split the molecule in hydrogen, the water molecule in hydrogen, oxygen will be less intensive. In steel industry, this will be also the temperature systems that actually we produce are requested also because the hydrogen is going to replace the coal as reducing agent for iron production, and the oxygen is widely used inside the factory for the steel making. For the decarbonization with hydrogen, we are touching different scenario, different situation. It is sure that in the future, the use of hydrogen producing, we can say, from by our machinery, with our machine, will be used more and more, even in the power generation. But we don't envisage the use of full cells systems, because this will be quite expensive. Hydrogen can be produced by exceeding power coming from the renewable energy systems, like wind turbine, also from the solar panels, solar plants, and so on. But this exceeding energy can be stored in hydrogen or even ammonia, but mainly in hydrogen, and used in different scenarios. Used as a co-fuel with methane to fuel the energy plant or steel plant, but also directly we can produce energy thanks to the new technology that actually is already applied in many different plants in Europe. We can call it 2 hydrogen oxygen recombination. That it is use the hydrogen and the oxygen also produced by the electrolysis system in order to produce a steam, high pressure steam, and to be fired inside a steam turbine. This is a new way, a new system that actually we are now step by step also thinking and to apply also in Europe. in order that we can utilize the exceeding hydrogen that is stored from the renewable energy, and also very important, oxygen that normally in the hydrogen industry is vent to the atmosphere. Here we can use as agent to start to burn and to produce a high pressure steam inside the steam turbine. So we have different topics. So we can say that starting from electrolysis systems, is possible to enter into the in different field and to find optimization together, because we need to share information, to share technology in order that we can get advantage to get as soon as possible the 2050 target, no carbon use. Because here in Europe it is a mandatory. Now is by law. We need to reach to 2050 the no carbon use, and this is a game changer. The system that I'm speaking now is here indicated. I will be available in the next future to explain how it is work. But we started from our machine to store hydrogen, and then from here we can do we can help to think about the with you the plant. Of course, not with us, because we are just a producer of hydrogen systems, but with our partners that can help you to reduce the emissions, CO2 emissions. It is now necessary now, according to our view, to combine the use of carbon like methane or natural gas, even coal, together with hydrogen, and step by step in the future reach to use 100% hydrogen. The applications are many, as you can see, and we are starting with the steel factory, with the buses, with railway, and also in the port in this moment. But we don't see in this moment an immediate use of hydrogen in transportation for cars, for example, because the system is too, we can say, requires some time to switch from combustion engines to electric and then to hydrogen. For any questions, sorry for the bad situation, but I'm leaving. I'm in the airport, so I'm leaving to very soon by plane. And for any inquiry, you can contact my partner in Futuristic Technology Solution, Ms. Vati Verna, that is available to any question and to also to put in contact each other and to discuss. Thank you very much.
Thank you, Mr. Saro. Thank you for your nice presentation. We'll just wait a minute for any questions. Meanwhile, can I ask you a question from my side?
Yes.
So, could you tell me what could be the cost implications for setting up a hydrogen plant? Could you give me a specific number in terms of dollars per ton or something like that? Meter cube, something
Okay.
like that?
No, for to producing the produce of hydrogen with our systems, it depends by the cost of the energy. That is simple. The cost of depend very much by this. In this moment, with the actual cost of renewable energy in Europe and Italy, consider also the cost of the machine, the capex. We can reach in this moment. We are between 2.5 to 3 euro per kilo of hydrogen. But if you start to recover oxygen, and we can start also to recover the hot water, the condensed water that is at 70, 60, 70 degrees, you start to recover the system. You can optimize. In the future, I think, but not too far, but in the next 2 or 3 years, this figure can be lower, especially if we can combine more machine together and optimize the system. For example, now we are studying with a big petrochemical company in Italy a system for 100 megawatt, and we will study all the optimization in order to reduce the cost and optimize also the flow of the heat and the recovery also the exceeding heat to be recovered. So it is in, I tell you, if we receive inquiry for 1 megawatt, or it is could be not so competitive. I tell you very clearly. But with the bigger plant, we have a problem. A very big plant. When I listen the gigawatt plant, the problem is the technology because it need a lot of space. Our aim is to reduce the size of the plant and also for example, the change we have for our system, you know, from PM and AM, the next future technology. Already we cut the cost of the platinum, iridium, and so the noble material. This is very important change, you know.
Okay, thank you, Mr. Saro. Another thing from my side was that what we are looking at in terms of in India is that the sectors like iron and steel, fertilizers, these kind of sectors would be the first one to adopt hydrogen as one of the technologies towards low carbon transition. What do you think? Where do you think power sector stands when it comes to maybe power generation through hydrogen? I mean, I hope you could understand my question.
But my background is I'm a chemical engineer and I was designer of a urea ammonia plant. I know very well your country. I was working many years ago as NAM Progetti that designed a lot of plants, and build up a lot of plants in your country. And so I know very well all the problematics. I envisage that there will be a possible production of ammonia using hydrogen, and this can be a first step. This will be a very big change to produce green, we can say green urea for the agriculture use. But one thing is important. I think I can see very fast application like we are doing here in Italy, in Germany, in the sector of the steel industry. Because in steel industry, they have a very big pressure and they need to substitute very fast, especially for the arc for furnace to substitute the carbon as a reducing agent to hydrogen. This is already a actual technology, and this will also be helped also by the use of oxygen produced by our machine. In fact, in Dalmine, Tenaris plant near Bergamo, there is already in discussion a 20 megawatt plant in order to reduce the use of carbon, and then to instead of CO2 we produce water, you know, and we can use the same agent as a reducing agent. So applications are many, but we need to think the most need industry, chemical, petrochemical, and also steel factory, then all the rest.
Okay. Thank you, Mr. Saru. Thank you for spending time with us. I think you are getting late.
No, I'm sorry, because I was in the place before, like ready for, but there was no noise. But now I need to rush to the check-in. I'm sorry very much.
Please. Yeah. Thank you, sir.
Okay.
That was
anyway, I'm available for any question in offline, no problem. Through my partner, and you can contact through you, no problem. Okay. This is the contact. Thank you very much.
Thank you for being here.
Bye-bye.
Have a great day. For the other participants, I regret to inform you the next presentation by Mr. Elisha Oliver Stone on cybersecurity solutions. He had some personal emergency. He'll not be able to be present here. We'll see if we can have him tomorrow. So that is from my side. With this, we can complete our Plant Summit Day 1. Thank you, everyone. Thank you, everyone, for being here. I hope you have enjoyed the entire day. I would request all of you to join for tomorrow. Tomorrow, we again start at 10:30. Really interesting session lined up on biomass, renewables, again, we have an interesting case study on hydrogen, how a coal-based power plant was converted into hydrogen-based power plant. So please join us tomorrow, a really interesting session. With this, we would like to close today. Thank you, friends, and have a great day. Take care.